Recording is an example of complex numbers, Loci. We're going to be looking at this situation where z minus z1 equals r. And what does that mean? Well, you can think of z minus z1 as the vector from z1. So here's the point z1, and here is z. And the vector from z1 to z is z minus z1, so that vector here. And we're saying that that vector has always the length r. In other words, it's all the points distance r from z1. And that, of course, forms a circle. So it's a circle, center z1, radius r. So you can think of this in terms of vectors, that z minus z1 is the vector from the constant point z1 to a general point z. And the length of that vector from z1 to z has to have a constant length of r. And here's an example. So z minus 2 plus 3i equals 5 is going to be a circle center. And be careful, it's not minus 2 plus 3i, but 2 minus 3i with the radius 5. Okay. So if we think of this point here as 2 minus 3i, and for example, this point here as being general z, then the vector from 2 minus 3i to z has length 5 will give us lots of possible values for z, which form a circle. And we can, of course, work with that. What I'm going to do now, though, is I'm going to show you how we can convert from this idea of complex numbers to Cartesian coordinates, and also see that we get the circle center 2 minus 3i, but in this case it will be with coordinates 2 minus 3 with the radius 5. And how we do that is that we will write z in the form x plus yi. But first of all, I want to just show you that whenever I write an expression like this, I normally would write it with z minus z1. And just to see what z1 is, it's going to be z minus 2. And then because we want plus 3i, we're going to need minus 3i in brackets. Okay, and this is just to emphasize that the center of the circle is 2 minus 3i. It isn't minus 2 plus 3i. Okay, so we're going to let z equal x plus iy, and then the statement that the modulus of z minus 2 plus 3i equals 5 becomes x plus iy minus 2 plus 3i equals 5. And if we collect the real parts and the imaginary parts, we get x minus 2 and y plus 3i equals 5. And then remember that the modulus of a plus bi is a squared plus b squared, square rooted, okay, which is just the length of a vector. In this case, it means that the length of x minus 2 is going to be x minus 2 squared plus y plus 3i is going to be y plus 3 squared. And we would square root that and get 5, or we can just leave it as it is and say that's going to be equal to 5 squared. And of course, this you should recognize is the equation of a circle, center 2 minus 3, radius 5. And you can see that that corresponds with the information here, coordinates 2 minus 3i with 2 minus 3, and radius 5 with the radius 5. So this course doesn't require you for this module to convert to Cartesian coordinates, but if you want to do so, you can do so by just letting z equal x plus iy, and then you get the x coordinate and the y coordinate coming out from the real and complex parts. I'll do some more videos on the other Loci problems to follow this.